Okay, there we go. Sorry about that. Had a bit of issues with the microphone. Welcome to Livecoding with Oddball. And today we are going to continue working on our Widget Anywhere app, which lets us basically screenshot any website and then make it a widget on your home screen, on your phone, tile on your Wear OS smartwatch, or even put it on the home screen of your Google Home Nest Hub display, smart display. So last time we got the snapshot editors working. So I can click this button, add button here, and have the website here. I can click, change website. We can hit snapshot, then take a snapshot here, save it, and change the duration or how often we want to take a snapshot and upload it to our Google Home or to our home screen widget. So you can see now, here it is added there, and if I go in here, it's got the snapshot area that I selected. Now, when we left, I was having some difficulties with Compose because things weren't saving correctly and states weren't updating. And I found this very important part of Compose that strangely is not in any of the tutorials or documentation I've seen. You have to just read the API docs. But it's really important. So you should definitely know about it. So see, for instance, here we had a duration that we show in the text box here, and this is derived from the snapshot that we loaded from the database. So you find, this is an actual duration, so you convert it to minutes, you divide it by 60 so you can get hours. And then we have a duration text, and that's actually the state of the actual text box, because when people are typing, it might be invalid. What if they type a letter or something? That's not a valid, hour duration. So you need to be able to keep that state so they can keep typing it and, fix it up. But you don't want to be updating your actual, duration that's supposed to be an integer. And you definitely don't want to save it to your database as they're getting it wrong. Now the difficulty here was that here's where we on value change. Here's where the text box changes while they're typing, and so we always save the duration text. That's the state of the text box. We just want whatever they type to show up, as they're typing it. And then here we try to parse a number from that, and if it works, then we can save the actual duration, and we make sure that yes, it is a valid duration. If it doesn't work, if they typed a letter or it's blank or something, then we want to set the error state to true. Pretty cool is error thing here, so Compose makes it really easy to just kind of highlight the text box and make it red. But basically, so this state, so this way we can the user can tell, when they've messed up and they can fix it. Now the problem was when you hit save, it was going up, it was calling basically it was calling on config saved. It would create a new snapshot with the duration. Then it would, go up to this composable. It would actually save to the database, to the view model. And that saves to the database. And then since we're observing the database of the view model in real time. Like, as soon as we save it, this now updates with the new value, and we recompose using the new value that we just saved. So nothing actually changes, but anyway, the problem was it was still using the old value that they typed here instead, like the original value it was rendered with, instead of the new value that we just saved. And the state was not like respecting that this snapshot had changed. And I found out by reading the documentation that you have to add your dependencies to as arguments to remember. That's the key. So if you are deriving your state from something else, and if that something else changes and you want like to recompute your state instead of remembering what it last was, you need to tell remember, hey, like whenever this snapshot changes, like this snapshot parameter from the database, whenever this changes, like just forget whatever state you had and reset it, derive it from this snapshot value basically. So you can see I've done that for duration. I've done that for duration text. So duration depends on the snapshot. If the snapshot changes, if the database loads something new, then we want to reset the duration to whatever that is. And then the duration text, we want to depend on duration here. So, if the duration from the snapshot changes, we want to update the text in the text box. But otherwise, we want, the person to be able to type and change stuff without actually having to change duration. So the state will change, and it'll remember it as long as this duration variable stays the same. But as soon as that changes, then this state gets wiped out and recalculated. So that's a pretty cool API. They should really kind of stress that in the docs somewhere, or make that very clear, because I'm sure it's a pretty common thing that you have to figure out. And I was searching all over, why is my state not updating when my parameters change? And couldn't figure it out. I just had to read the documentation and just stumble upon it basically. So anyway, let that be a tip for you. Maybe that's obvious to you, I don't know, or maybe that is somewhere in the docs that I just did not see. But so now we got our app working basically. We can save stuff, we can edit stuff. There's ugly save buttons. We should probably just save on edit instead of having the user actually press save, because that's kind of old school. But so now we have these things, and they're stored in an in-memory database right now. So we have our view model. Our view model has functions like add snapshot, update snapshot. And update is more of an upsert. So it's if the snapshot has not been saved yet, as evidenced by an ID that's less than 0, then we just add it instead. So really, we don't even really need add snapshot to be public, but it's fine. Get snapshot, this returns an observable, and we just observe this this observable, this behavior subject. So RxJava fanciness, we're just always saving things to this in-memory object. Whenever it updates, it lets get snapshots know, and then get snapshots will search the list to see if the ID that the user wants is in there, and then it will say, hey, this thing changed. So I think what we're going to do next is make this more permanent. So instead of an in-memory database, we can save it somewhere, so when you close the app and open it up again, you don't lose all your widgets. Typically this would be the time to use room, which is like a database, uses SQLite under the hood. But I don't really want to learn that. And I gotta work fast because my son's probably gonna wake up soon. So I'm gonna do something much simpler, which I usually like to do when, I mean, look at how many widgets are you really gonna have in this app? Probably not more than a screen full. Probably really not more than like 1 or 2. And if you're a real power user, maybe you got 10 or something. Probably more like 3. So do we really need to like spin up a whole database and write all the code to do that? Or can we just do the old fancy thing and save it to a text file? Or in this case, save it to shared preferences. So I'd much rather just do that. It's quick, it's easy, and the benefit is you're forcing you to serialize your objects, and I just like doing that because then you can just pass them to other places. Or, maybe later I want to upload these to a server for some reason. I can just do that because I've already got the serialization code in place. So I think what we're going to do here, so now we have this view model, and now the view model needs to take a repo somehow. Oh, so we need a factory, is that it? Cool, no documentation. Why would you need documentation on that? So I guess I should have looked this up first. How do we create a view model? I think right now we're creating it manually. No. You call this view model. You have to give it a factory, apparently. Anyway. Well, let's first just create the repo, because that's easy, right? So we're going to create a snapshot repo. And like I said, this is going to be really simple. Basically, we're going to have a where do we go here? So we have this. It's a list of snapshots. Oops. It's a list of snapshots. That's what we got in our repo. Okay. We'll keep this private. Don't want people looking in on our private things. And you know what? Actually, I think I'm just gonna actually make this a behavior subject, because that's actually way cooler. Because then we can just use all the fancy things of RxJava to subscribe to things and save whenever it changes. So really, I think I'm just gonna like copy most of this. It's pretty much. I mean, I pretty much wrote the repo in the view model, which I guess you're not supposed to do. But there is kind of some duplicate stuff there. Okay. Oh, great. So glad it added this for me. Oops. Alright, so now we have our methods, basically. Oh, is it actually being used? No, it's not. So now we can make, for now, we'll just make this a snapshot repo. Okay, and then we'll just change all these things to basically just return. It's kind of just a pass through. Okay, so we're just passing through everything. Oops. And now, if I want to be fancy in Kotlin, I can make all these one-liners, but I'm more lazy than fancy, so don't need any of this now. Alright, so now our model basically just talks to our repo. Our repo is over here. Our repo does stuff. That sounds like a good place to commit, since this is a pure, nice pure refactor. Okay, so refactor repo, add snapshot repo. View from view model directly. Okay. So now we got our repo there. Now we need to figure out how to basically how to make this not. Well, actually, let's write the fun part first, right? So right now this is like updating this in-memory list. And what we have to do is actually right now we're making an empty list, which, you know. So now what we're going to do, is take the context. Actually, I mean, so technically I should be making this an interface and an implementation, because that's going to come in handy later when we want to test things. But I'm not going to write any tests. Tests are boring. We don't need no tests. This is a fun app. No, tests are fun sometimes. Write your tests, kids. Okay. So, basically, on init, we're going to want to read the data from disk and then load it up. So let's do that. Let's go ahead and take a context text, and then we're going to make a prefs equals context shared preferences, and we're going to call it snapshot repo, and mode private as always. Private. So I never can. Oh, there we go. That's why. So, all right. So we have our shared preferences now. So now we can just prefs. You know what we're going to do here. We're just going to save it all in string. It's basically just going to be a big JSON file. Because JSON is awesome and prefs is lame. Like, it can't even store arrays? Like, really? Excuse me. Oh. Excuse me. Okay. Like, prefs is, like, really? All you can do is get string and get string set. You can't even get an ordered array of strings. Like, it's just like, well, I'll just give them to you in some kind of order. And that's it. So basically, shared prefs is kind of lame. Actually, I was reading something about where was it? It was something in Jetpack Compose. Oh yeah, so here's the documentation for Remember where I just figured this out. Very random. Like, oh, let me just read all the method definitions of Remember and maybe you'll figure it out. Sometimes that's what you gotta do. know there was some kind of, let's see, is there some kind of room or repo? No, shared preferences. Database, data layer. I think this is it. Data store. Oh yeah, so they have this data store thing. So they have preferences data store. And it's kind of silly because it's not actually, I think it just, like, what can you save in a data store? Probably the same things you can save in preferences. Like, ooh, wow, strings. Oh, a string set. Wow, like, why do they write this? We already know how to do this. And then, or you can save it as protos. Ooh, protos. Google loves protos. They are very efficient. They are also a pain to define. Like, you have to, like, write this code. Like, the computer should know. The computer has my object. It can figure this out. Like, why are you making me write this? So instead, we use good old JSON. Because JSON is awesome. And it's even more awesome when you use JSON because it will just automatically write the JSON for any object you give it. So quite nice. So anyway, so basically we're going to get string key snapshots. Okay. To give it a null value. So now I have to create this. Always put the companion at the bottom for some reason. Okay, that's our key. Oh, it's const. Okay, so snapshot, oops, shots JSON. So we're gonna have that there. We're gonna get our snapshots JSON, and then we're gonna do some magic to serialize it, or deserialize it here. And I bet you're asking, but how do you do that? Well, we add JSON. And how do you add JSON? Well, we type it in to the Goog. Then we copy and paste some stuff. There we go. JSON. You know, I'm so used to JSON, but there's got to be something better out there. JSON is actually very slow because it uses reflection. Oh no, what is this? Go away. Yeah, reflection is bad, okay? Okay, kids? Reflection is very slow on Android. They sped it up a little, but still generally, like, you want to avoid it. So I'm still waiting for someone to write a JSON parser that is, you know, built at compile time. So you read all the fields in your data model, and then build a perfectly optimized JSON parser for that object, like code generation. So you generate the code at compile time, and then you don't have to use reflection because you know exactly how the object looks, and you can just, you know, generate this custom code that parses everything from the JSON into the object without using reflection. And I'm not sure if that will, you know, actually save enough time to make it worth it building that library, but it seems like, you know, if you want a faster JSON library, that's how I'd do it. All right, so we added JSON. Now we need a little JSON builder thing. JSON equals JSON builder. And then I think there's not that much we have to do here. Free printing, we don't need that. It's lenient. I think we just create. We might have to do more later, but for now we just have this JSON parser now. And so now we can snapshots dot on next, and we're going to JSON dot from JSON snapshots JSON, and then we're going to tell it what kind of class it is, and we know already the list of snapshots. Okay. The problem here is, can you just use that? No. There's something special you have to do for lists. Type, class type. What I think we're going to need to do is create another object that basically just holds the list so JSON can figure it out. So that's not hard. Data class, snapshot list, and it's not even a data class. Oh, yes it is. Snapshots, and it's just a list. So that's all it is, and that way JSON, can serialize this a bit easier. Snapshot list, class.java. And what we can do, snapshots. So there we go, and that's only if it's not null. If it's null, then we load it. Okay, so we got our loading from disk. Now we need to save from disk. And since we're using a RxJava snapshots here, we can just subscribe to this, subscribe, and we have on next, which is basically this is whenever something is added to the in-memory database, we will now save it. And so we do prefs, edit, put string, key snapshots, and the serialized value. So JSON dot to JSON. Oops, no, we need snap list of it. And what's this going on here? You know what, actually we probably want to do this in here so we get the error handling. So map and we're going to use commit here, even though you should use apply in most cases. But this does it immediately, and then that way we can, know that it worked. And all we need to do is observe on a background thread. Schedulers.io, which is the background thread you use for writing to disk and stuff. So with this observe on, if you're not familiar with RxJava that much. You know, we're observing any changes to the snapshots. And then, you know, we map that. So if we get a new value, we edit the prefs, we put the string, we commit to disk immediately on this thread. And if this was on the main thread, you might have a little blip. You know, it doesn't take that long to save the disk, but you better do it on the background thread. It's better. It's nicer. So what we do is we add this observe on, and then that just runs everything below it on the background thread, on this IO thread. And that's how easy it is to do threading in RxJava. You know, Kotlin coroutines and Kotlin flows claim to be easier, but it takes more code than one line, I'll tell you that. So this is really the simplest thing you can do to just like get something on a background thread. So subscribe. We'll just print a nice success message, I guess. Save snapshots to disk. Whoop-a-doo. Okay, now let's make a tag. Snapshot repo. That's our tag there. Okay. No, how dare you. And then we also definitely want to check for errors. Oops, Colin is right, we want that. And for errors, we want to we're definitely going to log the error. Log the error. Oops, this is it. And the other thing we're going to want to do is maybe alert the user. That's probably important. So we don't actually do that here. I mean, yeah, we probably should, but now I realize the way we've architected this, you know, you're returning snapshots and you call on next. You can't really, since we are using RxJava now, you know, you can't really throw from here. But that's okay, because this app is quite wimpy, and we don't care. Please try again, or something. And usually they're just saving one snapshot, so. Oops. And then this is toast. Long. Show. Okay. Oops. And then, of course, we need the context here. Oh, actually, we have the context in init, which is kind of weird because now we're saving. We have it in this, lambda, so it's saved in the closure. So we just might want to make that explicit that we are saving this. Basically, so there we have our saving and loading done. Like, not that much work, right? Definitely less work than setting up a whole room repo and stuff. Now, I think one thing when we try to save a snapshot, let's see what we got here, rectf. So we have this rectf, and I think it's not going to know what to do with that. How do you serialize that? So we might have to tell JSON how to save that to, how to convert that to JSON. But for now, let's commit what we got. Repo add save snapshots to disk with repo add JSON library. Okay, so now we have that. So you may be asking, how do we do this? Oh, and also now we have this duration. Ugh, okay. Now we have all these things that we have to tell JSON how to do. But that's cool. We can do that. No problem. Blah, blah, blah. Snapshot repo. Let's put it over here. All right, so you remember when I created this JSON builder? What's neat here is you can register a type adapter factory. I think we just need a type adapter here. So type is rectf dot type. No, just rectf. Rectf type adapter. And we're going to create an object. Oh yes, that would be cool, wouldn't it? What does this mean? Object type adapter. What? Okay, what does this mean? What is type adapter? So, oh, interesting. Okay, so they just like, you have to pass in a raw object, and then you just have to know that it does this stuff. So that's interesting. Let's see. I think we need all of these things. So let's see here. Let's just make a type adapters file, I feel like. .json. Okay. And then this will inherit type adapter. F. And we'll also, extend. Actually, type adapter is fine. Structure. Okay, it needs a constructor. Now we need all these thingamajigs. Write and read. Is that what it is? Okay. I think we want to type adapter. I think there's easier ways to do this. Right, so there's also a JSON deserializer. What does this do? Deserialize. Alright, still the same. Serializer, deserializer, instance creator, and type adapter for this. See, these are null safe actually. So maybe we would rather have these. Let's see here. Yeah, so what we can do is just, yeah, because this requires you to deal with nulls. So instead we can just use a JSON serializer, which does not deal with nulls. But actually, you know what? Is this stuff null? Here, where's my snapshot? None of these are null, so we don't really need to worry about nulls. We have nulls, we have snapshot config with a duration. None of these are null. I think we'll be okay. But you know what? Just for safety, we're gonna do this instead. Blam, blam, badam, bam, bam. So now we have type of T, okay, JSON element, deserialize. Yeah, so for this we will just actually, you know what? I think we'll serialize this just fine. Yeah, JSON can figure this out. So JSON's actually very smart. It's like, oh, you have public members, and you have a no-args constructor. I can just set these. I can just create an empty thing and then set these, and it'll be fine. So recdef, we don't have to do that. Recdef, it will figure it out for us. One thing we do need to do is duration, I think. Duration is not so easy. Duration type adapter. So we're going to rename that. And so this is actually going to be duration. And so that's going to be more fun. So let's not have a constructor. Blah, blah, blah. So in this case, it's quite easy to deserialize, right? So we just have JSON element you know, these are never going to be null. So we're going to do as long, really. Yes. Cool. So you can even be fancy here and just be like equals now actually I think JSON they like you to use like the actual some RFC specification for storing dates. But for this, we'll just store longs right now because that's easier than string formatting and all that. We'll just store a timestamp, right? So duration of milliseconds. Probably don't need to be that fancy because, I mean, the UI only accepts hours. And we're definitely not going to be getting widgets every millisecond. But, you know, timestamps are always in milliseconds, so I feel like we just stick with the usual. Alright, so now we're also going to do a serializer. Duration. Also going to do a creator. Instance creator. Because it might need to create some fancy thing. Not sure. Duration definitely does not have a... So like instance creator gives us a default. Not sure why we would need that ever. In fact, we probably don't. So yeah, let's delete it. We don't need it. That's only if you have like, well, if you don't have these deserialized and serialized things. Okay, so first, remove the question marks. We know everything is not null. So we have, oh, a JSON element, interesting. Okay, so we're just gonna equal JSON element. Okay, how do we, what is this? How do we create, oh, JSON primitive, that's what we want. String, right, let me just pass it what we got. Source dot 2 milliseconds. So there we go. We just serialized and deserialized our duration. Just converting it to a long here. What does this give us? A number. Right. Fun. Okay, and I think that's all we need. Okay. So now we need to figure out what type. How do we do duration, interesting. Class dot Java object type. There we go. Isn't that fancy? Kotlin's got extensions for everything. So we've registered our type type adapter here. So now whenever JSON encounters a duration type, it knows how to serialize and deserialize that. And I think that should be it. I think we're good to go. Let's try it out. Oh, right. We're almost good to go. We need a context here. So we really should be passing this in to the view model. Let me just look up the docs because I'm not sure how view models, I haven't really used view models that much, so like how do they get injected? View model provider, that's probably what we want. Creates, okay, click on the thing, a default, can we path, okay. It provides view models for a scope. How do you do this in Compose? Compose view model provider. Alright, let's just, yeah, what happens? view model tutorial. It should be not that hard, but never pass down a view model, blah blah blah. Okay, but of course this is going to be too. Oh, this is not what we're going to want. We have a view model, blah blah blah. How do you get it from main activity? Blah blah blah. Wait, they didn't even say. The thing about tutorials is they always give you the most basic thing. Compose view model. Tell us how, please. View model, yes, call the view model function. Let me guess, they're not going to tell us how to do it. We have to read the view model. View model store owner. View model provider factory. How does the default factory work? That's what I want to know. Creation extras. What are these? Extras used to create the view model. What does this mean? Oh, it means you can pass things into, okay. If your view model has dependencies, it takes a factory as parameter. Okay. Yes. Great. So, yes. It takes a dependency. Okay. What do you mean? Oh, oops. Nope. Wrong place for that. Alright. So it takes our dependencies, which is the repo. But how do you create it now? It's something like this. You call view model here, but where do you get the context from here? Widget nav host. We have our activity here. Widget anywhere app. Member nav controller. Yeah, I really don't think you're supposed to be passing context to a composable. So how do you get that? They're not going to tell us in this. Okay, architecture, maybe that will tell us. Nope. View models. Well, let's read. What do they have for view model provider factory? Local model store owner. Don't know what that does. We don't care about that. Alright, what's the factory? What does the factory do? You have to pass in creation extras. Does that have a context? Android view model, what's this? What's this thing? Does this give us something good? No. Instance Android view model. I don't know what that is. Yeah, you still have to give it the application, so it's still not helpful. Let's just ask the old Stack Overflow. Pose view model factory context in view model factory. How to get context. Blah blah blah. Blah blah blah. No. Argument. Yes, we got the factory. Yep, still. Okay, view model providers of context view model factory. But how do you get the context into there? I think we actually have to pass it down. Okay. We just pass it down. But you can't pass context into a composable? That seems very bad. Whatever. Okay. So we have view model factory equals snapshot view model factory. Okay, and we'll create this somewhere. Put it in here, sure. Context, and this extends view model factory. View model provider. It's a provider, not a factory. View model store. Now we have to give it a store and a factory. Okay, maybe we just give it a, okay. View model factory. We did want a factory. We'll figure that out later. Well, we have a factory anyway. Model provider. Model provider. This, I guess. Model factory. And what we can do now is actually pass addition extras, and I guess we put the context in here for some reason. What do we do here? Abstract class. Android view model. Yes, here we go. Android view model does it for us. They did think of this after all. Oh, get the context in the view model. It just extends the Android view model class. What does this thing do? Don't need Android view model anti-pattern. Okay. Yes. No duh. Okay, blah blah blah. Okay, that's not helpful. Separation of concerns. Also not helpful. Yeah, we don't actually want the application on our view model. That is bad. Okay. View model store. Now we have to do this all manually. Where is the boilerplate? Let me copy and paste, please. Local view model store owner current. Okay. View model store owner current. Model store, I guess. Oh, okay. I don't understand this at all. How do you just... Oh my god. Just give me the boilerplate. Yes, okay. Is it... Do we have to provide it? Is this a... Oh. View model. Is the owner, does that have the context? No. What? What does it have here? Nothing. Absolutely nothing. Android view model factory. Still not very helpful. Interesting. Okay, so we do We have an Android view model factory. Oh boy, this really should be much easier. Yeah, this is not great documentation. How about you just tell me what to do? Oops. Alright, maybe it's in here. Is it in here? View models and compose. Blah blah blah. Screen level composables. Factory. Greeting view model factory. Yeah, this is not helpful. These contrived examples are the bane of this documentation. Like, why would I need a factory for this crap? This is like doesn't mean anything. Oh boy. View system as a source of truth. Compose as a source of truth. Still not helpful. Okay. Yeah, how do you... Okay. What about this? String resource. What's this? So they do have... They have access to the context somehow. Okay, it's very annoying. Oh yeah. I believe there's some kind of example app that I was looking at. Not this one. Not this. Definitely not that. Yes, this one. Okay. Look at the architecture samples. Okay, how do you pass it the repo? See, I think this is using Hilt, so it's a lot easier if you use Hilt. To do nav graph. See, look, how do they get the view model? I don't? Do they even have a view model? Yes. Okay, where does data source? Somewhere in here you're gonna have to like load from context. Pretty sure. Room database. No, none of these. Okay, they really want to fight you on this to do nav graph. This is a nav graph. I don't think they even have a view model. Here's a view model. Does it accept the repo? Yes, it does. And it's Hilt. That's why. So much easier when you use Hilt, really. Because somehow it can just inject the view model somewhere. Yeah, into the screen here. Alright. How do you do it without Hilt, please? Don't need to set that up just for this. model view provider. Create view, model view provider with this. My Android view model. Okay, I guess you can just, interesting. So this is kind of, I agree with that guy who said don't do this, but at the same time, like, what else am I supposed to do? All right, let's just save what we got here. What do we have here? What did we add? It's not this. We did not want that. But we have, yes, we added, yeah. Use snapshot repo in view model. It's pretty much what we're, oops. And also we add duration type adapter for JSON. Oops. Okay. So we're just not, this is, I don't know what this is. It sucks, basically. So now our view model, interesting. So I guess you just Android view model. And what's this? Application, okay, blah, blah, blah. So now we have that. And now we kind of basically snapshots equals, and we create a new snapshot repo with the application. So the problem is when they rotate and stuff, we're going to reload everything, but let's just see if this works. That's what I want to see. I want to see it work, dang it. I want to see it work. What's this do? Oh yeah, we don't need this. Well, we'll just throw that out in a bit. Let's see it load up. Let's see what kind of errors we get. Okay. We got this going on. It's loading, it's running, it's do. Nope. What's happening? Oh. What is this now? Oh, I think this should be actually snapshot defaults. There we go. Made a default snapshot just so we can use them in all the previews. It's weird that it broke now. It was working fine for a while. All right, here we go. And it crashed. No. Oh, it's installing. It's installing. It's opening up. What's happening? It's loaded. All right. Change this to 12 hours. Save. Okay. What happened? Did it save? Let's see. Save snapshots to disk. Okay. So let's kill it. Reload it. Will it load? Oops. Right. That's not the correct manifested. Okay. So main activity is not actually the one we want. We are going to, now it's edit snapshots activity. This activity is nothing anymore. But we're going to rerun it, and it should load. Anyway, moment of truth. Here we go. Let's see. Will it load? Boom! Look at that. It showed up. It loaded. Look at that. Save snapshots to disk. Oh, yeah. So the funny thing is, like, it saves it as soon as it loads it. And we can actually avoid that. See right here, because we load the snapshots and then we observe the snapshots, so we get, you know, the latest one, which is, you know, the one we just loaded. So I think what we can do is just skip the first one there, but that's for another time. What do we got here? All right. Android view model. Not the best, but whatever. So we're just going to amend that because now it actually works. What does this do? Yeah, we don't need any of that. And the manifest. So we fix that. I'm just gonna get rid of that snapshot list. We fix snapshot list preview compile. Somehow it was working before. And this, we're just going to discard this whole file because it gives us nothing. Well, we'll stash it. Maybe it'll be useful one day. Okay. So there we go. Now I think what we will do here is we'll just ignore the first one, because we know that's the one we're going to load. So that way we're not like loading it and then immediately saving what we just loaded to disk, even though nothing changed. So now if we look at our logs, it should load only and not save. Let's see, we got the load somewhere in here, probably. Where did it go? Where did it go? Oh, right. It doesn't actually tell us when it loads. It just works. Right? Okay, so it didn't save. So that's cool. All right, let's do some more testing here. Perp. What is that? Is that a website? No, it is not. Purple is, though. snapshot this thing. Save. Save over 11 hours, sure. Okay. So now we go here. And we have that. Let's see if it's saved to disk with our rect and everything. See if it saved our snapshot to disk. Yes, it did. Look at that. Cool. Very cool. So that took a bit longer than that was the quick way, and it still took, a bit longer than I thought to make the snapshot repo. Kind of really got caught up on the whole view model business. They really don't make it easy for you if you're not using Hilt. If you're making a real app, I do recommend Hilt. It makes things much easier to test, and much like if you have a bigger scale app, then you're gonna like it in the end because it gets rid of a lot of boilerplate and stuff. It adds its own boilerplate, but it's pretty nice. Don't fix this. Don't save the initial load. Shall load. Good. And this is in the repo. Okay. All right. With that done, we have our repo. We save to disk now. Stay tuned next time, where we will actually start a service to go and capture these things. It will load, what snapshots we have in the repo, and then it will, actually capture the website's screenshots and do something with them. So like and subscribe, and stay tuned for the next episode. Thanks for watching. Bye-bye.